Hello everyone, this is Dr. A.P. Hivrekar from Vidyapratishthan's Kamal Nayan Bajaj Institute of Engineering and Technology, Baramati. Today we are going to discuss half-range Fourier cosine series. So, outline of this lecture is as follows. We'll first look at what are the applications of Fourier cosine series. Then we will see that what actually Fourier cosine series is. Then we will look at method of solving problems, and finally we discuss problems on half range Fourier cosine series. Applications of Fourier cosine series. It is useful in converting complex waveforms into a simpler harmonic components. It has applications in signal processing, vibrational analysis in mechanical system, in telecommunication engineering. It has applications in acoustic engineering. It has many applications. I have mentioned only few, but the area of application of Fourier cosine is very large. Method of solving problems. We will see how to deal with the problems when we are solving Fourier cosine series problems. So first step is write formula for half range Fourier cosine series, which is given by fx is equal to a0 by 2 plus sigma an cos of n pi x by l, where n varies from 1 to infinity. In this case, bn is 0 and we have interval 0 less than x less than l. So that is our interval. Then after that we will find value of l from the given interval, comparing it with the standard one. Then we find value of a0, which is given by 2 by l integration 0 to l fx dx. After that we will find value of an by applying formula 2 by l integration of fx cos of n pi x by l dx, where limits for integration are 0 to l. And once we have components a0 and an, we substitute those components here, and from that we get final value of a function, which is Fourier series of function fx. So half range Fourier cosine series, just we have seen all these formulas: formula for fx, formula for a0, formula for an. Now actually we will solve few examples, like find half range Fourier cosine series for function fx is equal to pi x minus x square in the interval 0 to pi. So to deal with this problem, we will follow method, that is, first we have to look at all these formulas, that is, interval, standard interval is 0 less than x less than or equal to l. Formula for fx a0 by 2 plus sigma an cos of n pi x by l, where n is from 1 to infinity. So Fourier coefficient bn, when we are finding Fourier half range Fourier cosine series, will be 0. Then formula for a0 2 by l integration of fx dx from 0 to l. An is 2 by l integration of fx cos of n pi x by l dx. Limits for integration are 0 to l. Now here a0 is 2 by l integration of fx dx from 0 to l. We have given f as we have interval 0 less. So first we will find value of l. as we know, standard interval is 0 less than or equal to x less than or equal to L. So obviously here L value is pi. So formula for A0 is 2 by pi integration 0 to pi, and f of x is pi x minus x square, then dx. Now we need to integrate this. So for that we have 2 by pi integration of pi into integration of x is x square by 2, then integration of x square is x cube divided by 3, so it is x cube by 3. Limits for integration are 0 to pi. So we have this value as 2 by pi, then it will be, for upper limit we have to calculate value, because for lower limit it becomes 0 because x is 0. So it is pi into pi square, that gives pi cube divided by 2 minus this is pi cube by 3. So if we calculate this, it will be 2 by pi, then pi cube is common, then this will be 1 by 2 minus 1 by 3, and finally it gives 1 pi get cancelled, so it is 2 by 6 into pi square, or that is pi square by 3, pi square divided by 3. So final answer means A0 is pi square by 3. So A0 is pi square by 3. Now we will find value of An. Formula for An is 2 by L 0 to L fx cos of n pi x by L dx. Here fx is pi x minus x square, interval is 0 less than or equal to x less than or equal to pi. Obviously we have already calculated value of L is pi. So A0 is 2 by pi 0 to pi, f of x is pi x minus x square into cos of n pi x divided by L. L is pi. So if you calculate this angle, that gives nx. So cos of nx dx. Now to evaluate this integral further, we have standard result, that is what integration of uv dx is uv1 minus u dash v2 plus u double dash v3 minus and so on. So v1 is integration of v, and u dash is derivative of u. So we evaluate this integral further. So it is 2 by pi, first function means pi x minus x square as it is. Then integration of cos nx, we know that is sin nx by n. So this will be sin nx divided by n minus derivative of pi x minus x square, that will be pi minus 2x. Integration of sin is minus cos, so that's why it is cos of nx divided by n into n, that gives n square. Then plus derivative of pi minus 2x is minus 2. Integration of cos is sin, so this is minus sin nx divided by n square into n, that gives n cube, and next term will not be there because derivative of 2 will be 0 and limits for integration are 0 to pi. Now to simplify this, sine of 0 is 0, that's why this term is 0. Sine of n pi is also 0. So for upper and lower limit, third term will be 0. And similar way, sine of n pi is 0, sine of 0 is 0. So first term and third term, both terms become 0. Only we need to calculate middle term with upper as well as lower limit, because we know sine of 0 is 0, sine of n pi is also 0. So we have to calculate only middle term. So for that, what we do is, it is 2 by pi. First we will see what is sine of this term. So it is minus of minus is plus. So 2 by pi n square, I will take it common outside. Then apply upper limit, means x is pi. So for upper limit is pi minus 2 pi into cos of n pi minus apply x as 0. So it is pi minus 0 is pi into cos 0. Okay. So this will be 2 by pi into n square. Then pi minus 2 pi is minus pi. Cos of n pi, we know that cos of n pi is minus 1 power n. Cos of 0 is 1. So it is minus 1 power n. Then this is minus pi into cos of 0 is 1. So finally we get this value, as minus is taken common, pi get cancelled. So it is minus 2 by n square minus 1 power n, minus of minus is plus, because minus is already taken common out. So value of an is minus 2 by n square minus 1 power n plus 1. So with this, now we find value of fx by substituting values of a0 as well as an. So value of a0, so fx is a0 by 2 plus sigma an cos of n pi x by l, where n is from 1 to infinity. A0 value is pi square by 3, so a0 by 2 will be pi square divided by 6, minus 2 is common, then sigma minus 1 power n plus 1 divided by n square into cos of nx, where n is from 1 to infinity. So this is value of fx, which is given by pi x minus x square, and that will be our final answer. So next problem will be find half range of function fx is equal to x in interval 0 less than or equal to x less than or equal to pi. So obviously we have interval as 0 to L, then formula for fx as a0 by 2 plus sigma an cos of n pi x by l, where n is from 1 to infinity. In this case, value of bn is 0, and these are formulas for a0 and an. Now first we find value of a0. For that we have fx as x, interval is pi. So length of interval in standard formula is L, and here it is pi. So we have L is pi. So formula for a0 will be 2 by pi 0 to pi, value of fx is x, then it is dx. So it will 2 by pi, integration of x is x square divided by 2 from 0 to pi, and obviously for lower limit it will be 0, and for upper limit it will be pi square by 2. So it is 2 by pi, then it is pi square divided by 2. So that gives 1 pi get cancelled, and we get value of a0 as pi. So a0 is pi. After that we will find another coefficient, which is an. Formula for an is 2 by L 0 to L fx cos of n pi x by L dx. And here we have already seen value of L is pi. So in this case value of an is 2 by pi integration 0 to pi x into cos of n pi x by L, but L is pi, so this is n pi x by pi. Pi get cancelled, and we have angle as nx, so cos of nx dx. So to evaluate this integral, we have formula integration of uv dx, that is uv1 minus u dash v2 plus u double dash v3 minus and so on. So when it is at or ae. So here algebraic function is x and trigonometric function is cos nx. So it will be 2 by pi, first function x as it is, integration of cos is sine, so this will be sine nx divided by n, minus derivative of x is 1, integration of sine is minus cos, so this is minus cos nx divided by n square. Next term will not be there because derivative of 1 is 0. And obviously when we look at, and obviously as we know, sine of 0 is 0, and sine of n pi, where we are assuming n as natural number, so that is 0. So this term for upper limit as well as lower limit becomes 0. So it will be 2 by pi. We need to calculate this term for upper as well as lower limit. Its sign is plus, so 1 by n square, so 2 by pi into n square is common. Then here we apply upper limit as pi, so for upper limit it is cos of n pi, and for lower limit it will be cos 0. And we know that cos of n pi is minus 1 power n, and cos of 0 is 1. So we have this value as 2 by pi into n square, cos of n pi is minus 1 power n, cos 0 is 1. So value of an is 2 by pi into n square in bracket minus 1 power n minus 1. So we have this. Then finally we have to find value of fx. So fx is given by a0 by 2 plus sigma an cos of n pi x by L with n as 1 to infinity, and value of a0 we got as pi, so a0 by 2 will be pi by 2. Then value of an we substitute, from that we can take 2 by pi outside sigma notation, then inside it is minus 1 power n minus 1 divided by n square, and cosine of angle nx, where n is from 1 to infinity. So that is value of fx, which is given by x and interval is 0 less than or equal to x less than or equal to y. So that will be our final answer. That is Fourier cosine series for function fx which is equal to x in the interval 0 to pi. So we move to next problem. Find half-range Fourier cosine series for function 2x minus 1 and interval is 0 less than or equal to x less than or equal to 1. So half-range cosine series is given by fx is equal to a0 by 2 plus sigma an cos of n pi x by l with bn as 0 and interval is 0 less than or x 0 less than or equal to x less than or equal to l. These are formulas for a0 and an. Now first we try to find value of a0. So formula for a0 is 2 by l 0 to l fx dx. Give 2x minus 1 and interval is 0 less than or equal to x less than or equal to 1. So here value of L, length of interval is 1. So it is 2 by 1, 0 to 1, fx is 2x minus 1 dx. We integrate this. Is 2 outside, integration of 2 into integration of x is x square by 2 minus integration of 1 dx means x, limits 0 to 1. Limits are 0 to 1. Obviously for lower limit both terms become 0. We need to only calculate this term for upper limit. So 2 is outside common, this 2 get cancelled, and for upper limit 1 square is 1 minus 1. So 1 minus 1 is 0. So we get value of a0 as 0. So a0 value is 0. Then after that we will find value of an, which is given by an is 2 by l 0 to l fx cos of n pi x by l dx, where fx is 2x minus 1, l is 1, so it will be 2 by 1 integration 0 to 1 fx is 2x minus 1 into cos into cosine into sine of angle we will calculate n pi x, l is 1, so it is n pi x, so it is cos of n pi x then dx. Okay, so we have formula integration uv dx, which is uv1 minus u dash v2 plus u double dash v3 minus and so on when function is at or ae, means algebraic into trigonometric or algebraic into exponential. So it is 2 by 1, then first function 2x minus 1 as it is, integration of cos is sine, so this is sine of n pi x divided by n pi minus derivative of 2x minus 1 is 2, integration of sine is minus cos, so it is cos of n pi x divided by n pi into n pi is n square pi square. Next term will not be there because derivative of 2 will be 0. Now once we get this, we will see that which term becomes 0. As we know, sine of 0 is 0, sine of n pi is also 0. So when we apply upper limit as 1, x is 1, this becomes sine of n pi. So that's why this term becomes 0. For lower limit it becomes sine of 0. So that's why this term becomes 0. So it will be 2 into 2, minus of minus plus, so 4 by n square pi square is common. Then we need to calculate this term for upper as well as lower limit. So for upper limit it is cos of n pi, x is 1, so it is cos of n pi, minus for lower limit it will be cos 0. So we get this value as 4 by n square pi square. Cos of n pi is minus 1 power n. Cos of 0 is 1. So this will be minus 1 power n minus 1. Okay. So finally we have value of fx. So fx value we will calculate by applying standard formula. So a0 value we got, an value we got. Now we calculate fx. What is formula for fx? Fx is a0 by 2 plus sigma an cos of n pi x by l with n is 1 to infinity. Value of a0 we have got as 0 and value of an is 4 by pi square we can take outside, sigma notation minus 1 power n minus 1 divided by n square into cos of n pi x. So that is value of fx, and fx here is given as 2x minus 1 and interval is given as 0 less than x less than 1. So this is final answer means half range Fourier cosine series for function 2x minus 1 as this. So next problem will be find half range Fourier cosine series for function 2 minus x and interval is 0 less than x less than or equal to 2. So we have formulas for fx, a0 and an as usual. So in this case value of bn is 0. This is formula for fx. This is formula for a0. This is formula for an. First we calculate value of a0 which is given by 2 by l 0 to l fx dx. Fx is 2 minus x. So length of interval here is 2 and for half range length is L, so therefore L is 2. So it will be 2 by 2, 0 to 2, f of x is 2 minus x and then dx. So it will be integration of 2 is 2x, integration of x is x square by 2, limits are 0 to 2. Apply this limit. So it is 2 into 2 is 4 for upper limit, minus 4 by 2 is 2, and for lower limit obviously it is 0. So it will be 2. So value of a0 is 2. Value of a0 is 2. Okay. Once we find value of a0, then after that we will find value of an, which is given by an is 2 by l 0 to l fx cos of n pi x by l dx, where fx is 2 minus x, length of interval is 2 here, so value of l is 2. So value of an is 2 by 2, 0 to 2, 2 minus x. Then what about this angle? Cos of n pi x, L is 2. So angle is n pi x by 2. So this is cos of n pi x by 2 then dx. So it is Again we have formula, integration of uv dx is uv1 minus u dash v2 plus u double dash v3 minus and so on. First function as it is, what is that? 2 minus x integration of cos of ax dx is sin of ax divided by a, and here a is n pi by 2. So 1 by a is 2 by n pi. So that's why it is 2 by n pi into sin of n pi x by 2. Next term will be derivative of 2 minus x is minus 1. Integration of sin is minus cos. So that's why it is 2 into 2 is 4 divided by n square pi square into cos of n pi x by 2 with limits as 0 to 2, because for next term derivative of minus 1 will be 0. This term becomes 0. Why? Because we know sin of 0 is 0, and when we substitute x as 2 we get sin of n pi, and sin of n pi is also 0. So here if we want to calculate this term, we get cos of n pi, and cos of n pi is minus 1 power n. For lower limit this is cos of 0, and cos 0 is 1. So this term becomes 0 for upper as well as lower limit, not required to calculate. So this will be minus of minus of minus will be minus, and so that's why it is minus 4 divided by n square pi square. We apply upper limit, means x as 2, so n pi into 2 divided by 2 get cancelled, so it is cos of n pi for upper limit, minus it will be cos 0, and that's why it is minus 4 divided by n square pi square. Further if you simplify, it gives minus 1 power n minus 1, and if you want you can write this by removing minus n, otherwise you can keep it like this. So value of a n is minus 4 by n square pi square into minus 1 power n minus 1. So value of fx now we calculate. So value of fx formula is a0 by 2 plus sigma an cos of n pi x by l with n as 1 to infinity. And in this case we have got value of a0 as 2, so 2 by 2 is 1, then it is minus, minus. So what is that term? 4 by pi square, we can take it outside, sigma, then this will be cos of n pi x by 2, this divided by n square with n as 1 to infinity, with n as 1 to infinity. So 4 by pi square is taken common, and this is value of fx, and fx means what? 2 minus x, where interval is given as 0 less than x less than 2. So this is final expression for half-range Fourier cosine series fx, which is 2 minus x, defined in the interval 0 less than or equal to x less than or equal to 2, less than 2, 0 less than x less than 2. So now we will move to another problem. Find half-range Fourier cosine series for function fx is equal to x square defined in the interval 0 less than x less than or equal less than pi. So these are formulas for fx, a0 and an, and in this case value of bn is 0. So we try to calculate first value of a0. We have given function fx as x square, 0 less than x less than pi. So we try to calculate first L value. So length of interval is pi. So L is pi. So it will be a0 is 2 by pi, 0 to pi, fx is x square and then dx. So it is 2 by pi, integration of x square is x cube by 3 from 0 to pi, and obviously for lower limit it becomes 0. So it is 2 by pi, then for upper limit it will be pi cube by 3. So if you calculate, simplify it further, we will get value of a0 as 2 pi square divided by 3. So value of a0 is 2 pi square by 3. After this, we will calculate value of an, which is given by an is 2 by L fx into cos of n pi x dx, where fx is x square, interval is 0 less than x less than or equal to pi. So we calculate value of an. Obviously we have L is pi, so it will be 2 by pi integration 0 to pi x square into cos of n pi x by L. L is pi, so pi pi get cancelled and this angle becomes nx. So it is cos nx dx. So to simplify it further, we have integration uv dx when function is at or ae, algebraic into trigonometric or algebraic into exponential, it is uv1 minus u dash v2 plus u double dash v3 and so on. 2 by pi outside as it is, then algebraic function is x square, so first function u as it is, integration of cos is sine, so it is sin nx divided by n minus derivative of x square is 2x, integration of sine is minus cos, so this is cos of nx divided by n square, n into n is n square, minus of, it is plus derivative of 2x is 2, integration of cos is sine, so that's why it is minus sine of nx divided by n square into n, that gives n cube, and limits for integration are 0 to pi. Okay. Now further, by a sine 0 is 0, sine of n pi when n is natural number, it is 0, then cos of n pi minus 1 power n, cos 0 is 1. Now if you look at this term, when we apply upper limit, sine of n pi, and sine of n pi is 0, that's why this term becomes 0. Due to sine 0, this term becomes 0. So first term for upper as well as lower limit becomes 0. And similar way, last term, sine of n pi is 0, sine of 0 is 0, that becomes 0. This middle term, when we substitute x as 0, this becomes 0 for lower limit, means only we have to calculate middle term for upper limit, and therefore it is 2 by pi common, then n square is also common, minus of minus is plus, then apply upper limit, means x as pi, so it is 2 pi into cos of n pi. Okay, so 1 pi get cancelled, 2 into 2 that gives 4, 4 by n square, cos of n pi is minus 1 power n. So value of an is 4 by n square into minus 1 power n. So an is 4 into minus 1 power n by n square. Finally, we'll calculate value of fx, which is given by fx is equal to a0 by 2 plus sigma an cos of n pi x by l, with n is 1 to infinity. Value of a0 we got as 2 pi square by 3. So a0 by 2 will be pi square by 3 plus sigma. From sigma notation we can take 4 common. Then this will be minus 1 power n divided by n square into cos of nx, where n is from 1 to infinity. So this is final answer, means Fourier series for fx, which is given by x square in the interval 0 less than x less than pi. So that is our final answer. So wish you all the best, happy learning, and thank you very much for watching this particular video. Thanks to all.